Why doesn't sunlight illuminate space? Child's question for the ISS answered. When he went to space, Star Trek actor William Shatner was struck by the darkness. The stream of sunlight never illuminates you. When Star Trek star William Shatner returned from space, he said it felt like a funeral. I saw a cold, dark, black void. It was unlike any darkness you could see or feel on Earth. It was something profound, all-encompassing, all-consuming. I turned to the light of the house. I could see the curvature of the Earth, the beige of the desert, the white of the clouds and the blue of the sky. It was life. Outer space is always dark. Although it is relatively close to the sun, it is profoundly black. That's how cinema imagined it long before Star Trek, and that's how we've seen it in countless space launches and productions. Why doesn't the sun illuminate space? A child asked astronauts on the International Space Station, ISS, this same question several years ago. That's a good question, and here's the answer. An intense light source. The sun, like any star, is an intense source of light. Much of its energy is released in the form of electromagnetic radiation that it emits in all directions in a spherical format. Most of this radiation is emitted in the visible, that is, as a stream of light. We know that the intensity of sunlight decreases with distance. An object twice as far from the sun as Earth will receive a quarter of this brightness. This occurs because the sun projects a finite stream of light over an increasingly larger spherical area. Consequently, Mars receives less light than Earth, but more than Saturn, which is even more distant. Looking at it another way, although light decays rapidly with distance, interplanetary space near Earth receives a flux of radiation similar to that received by our planet. The sun radiates a light into space, but it does not illuminate it uniformly, as happens in the sky on Earth. Vacuum does not reflect light. To understand why sunlight does not illuminate the space, simply turn on a lamp in an open place, and another in a room painted white. The lamp barely illuminates a small circle around it, in the open space, but manages to illuminate the closed room more or less evenly. Lighting a space requires not only a light source, but also something that disperses or reflects it, like the white walls of the room. A better example would be pointing a flashlight at the sky. If there is a lot of humidity, we will see the beam of light up to a certain distance, but otherwise it will hardly have any effect. On the illuminated half of Earth, light is spread evenly by the atmosphere, which is made up of small particles. Space is practically empty. It has no particles to scatter light. The luminescence is there, and if you look directly at the sun you risk going blind, but there is nothing to disperse or reflect it to illuminate the space evenly. It's the same reason Earth's sky is blue, Mars' sky is reddish-gray, and the moon has no sky. Different atmospheres, or lack thereof, scatter light in different ways, or not at all. There is a lot of light in space, but this light only becomes visible when you look at the source, or an object that reflected it.